code walkthrough of our project titled Income Inequality in the World. And this is intended for those who are familiar with Python and with coding to show the process of how we gathered our data and created visualizations. So to begin, we uploaded our CSV files. So we began with this Gini CSV file that we got from World Bank that shows the Gini indexes for different countries across the world in a time period from 1978 to 2007. So that was the range that we were looking at. And our first thing was to import this CSV file and create a list out of it with the data from it. And then we saw that there were a lot of countries that had no data points whatsoever. And so we decided to remove those, and we did so here. So that was just cleaning up our data, and then we printed all the lines to make sure that we did it accurately and didn't mix up any countries based on their index numbers. So this is one way of looking at the data that we had gathered, but we needed to organize the data. So we started by doing different lists. This is the country list of all the countries that had data points. So what was left in our data set. And from here, we created a dictionary where the key was, where the key was the country name, and then the values were the data points that had been reported from that country. And then using this dictionary, we created a data frame, and this had all the countries that were remaining in our data set that had data points in the same range of years. So that's again from 1978 to 2007. Then we also here imported the Gapminder data set because we knew that this was something that we wanted to consider in drawing our conclusions, especially the population and the GDP per capita data that was reported in this data set. So our next step was to, we wanted to compare different years in the data set. However, we realized that this was not the best course of action because there were a lot of years that just did not have a lot of data reported. And so from there, we decided not to deal with the different years, but rather to deal with a specific country that we knew did have a lot of data points, and that was Brazil, which we will look at later. So for this, for our first two visualizations, we used the Gapminder data set to look at data points from the world in general. Here we uploaded it. Again, we took a look at the Gapminder, the head here. Here's some info just so we can look. This was life expectancy. We considered originally comparing life expectancy to other values, specifically the Gini index, but also GDP per capita. But we decided that this wasn't going to be very beneficial to us. And so we did create this visualization, but decided not to go down that route and instead focus on other things. So here we have the GDP per capita over time, which we created using the Gapminder data frame or data set. This is the visualization of how the GDP per capita in the world changes over time. And we did a very similar visualization for the population of the world over time. So having already analyzed the data from around the world, we wanted to focus specifically on Brazil, which had the most data points available for us. However, there were a couple missing data points. So for this, when we tried to do it originally, we ran into a lot of problems with having 0 values for certain years in Brazil. So we knew that we had to, in order to have an accurate visualization that wasn't skewed based on those 0 values, we had to put data points there. So for a couple of these, we filled in the averages of the points in between the missing data points to estimate what the Gini index would be in those years when there was no data reported. And then we had a list made from this. And we made sure that these were all floats, and then put it into another more clean list so that we wouldn't run into issues later with our visualization. And then since we were analyzing the world population above, we wanted to analyze Brazil's population as well. So we found another CSV file, again from World Bank, which we used and cleaned. And this is showing specifically Brazil's population. And we also had the same process for Brazil's GDP over the years. And again, here we just made sure that they were clean and easy to understand so we wouldn't run into issues with our visualization. So here we made a dictionary. We brought in the years list as well as an index list so that the data could be portrayed in more of a straightforward manner. So we used the zip function to bring together the index list and then compare the years, the GDP of Brazil, the Gini index of Brazil, and the population of Brazil into a Brazil dictionary. And then use that dictionary to create a data frame. And this was one of the most helpful parts of our project, was to see all these values side by side rather than in separate lists. Especially going forward with our conclusions, it was nice to see specifically the different values and how they relate to each other here. And then taking that, we made 2 more visualizations. And this is just the Gini index for the world as a whole. And we referenced the Plotly Express website that we have used before in class to figure out how to make 2 y-axes so that we could show accurately both the Gini index and the GDP per capita on the same graph. So this is the code that we used. And it shows, we can see specific data points here of what the Gini index was in certain years compared to what the GDP per capita of Brazil was in certain years. And one conclusion that we drew from this is that typically, as we see in this range as well as in this range, the Gini index tends to be higher when the GDP per capita of Brazil is lower, and vice versa. So when the GDP is higher, the Gini index tends to be lower. And so we thought that that was an interesting observation, and we considered that very much when we were drawing our conclusions. And we used the same format to create another visualization, this time comparing Brazil's population versus Gini index over time. And when we first started this project, we expected there to be a significant relationship between the two, but we really did not see a very direct relationship. As expected, population just increases pretty steadily, and we do see changes in the Gini index, but we can't say that those are for sure caused by changes in population, because there are clearly a lot of other factors that go into the Gini index. And so this was something that we were surprised by because we thought that there would be more of a correlation. And so these are our 2 visualizations for Brazil specifically. And then from here, we put all of our findings as well as our visualizations onto the website, which we will go over in our demo video.